I wanted to introduce the task Parker extension. So this was something Martin first started working on back in 2019, and we finally finished getting it done in May this year, just because of the lack of time and with other priorities here. But this is going to be a small talk. I wanted to introduce this to just give you guys an idea of what you can use this for. But okay, let's go back in time a bit and look at what the task states looked like before version 3.8. So this is just a simple figure here, so showing the transition of states for a specific task, like it goes from ready to running and then running to done. And ready is when it's still trying to acquire a thread, and running is when it's actually doing its work, and done is when the task is actually done. So there are a couple of the states, cancelled and sleeping, but we are not gonna talk about it for the scope of this talk. Okay, so then in 3.8, also a change that Martin did, he added extension task listener, where before the task actually starts running, plugins can register a task listener where they can implement the on start and on stop methods to do specific things before and after a task actually starts running. So some of the use cases for this would be to like keep track of resources that are being used. You can kind of have metrics in there in your on stop and on start methods, and you can probably even do this to delay the start of your task based on some of the resource requirements that you have. So this was available in 3.8, but yeah, like you can see here, I think one of the problems here is that like once you start blocking a task after it starts running, like in this case after it acquires a thread, that means that thread is essentially blocked and it's no longer usable for any other tasks that are running on the same service, and they have to wait for a worker thread to be available before they can actually make progress. So this was 3.8, and then now we have task Parker. So I am not showing the on start and on stop kind of labels here, just to simplify this a bit. But this is, I think, explains it pretty well. So you have the same kind of states as before. The new state that, so in the previous extension, the new states were starting and stopping, which are kind of bolded here that you can see, were introduced by the task listener interface. And now with the task Parker, the new state that you have is parked. So essentially now when task starts, again, you have the same ready state then followed by starting that was introduced with the listener. And now we have this these two new methods that the task Parker interface kind of exposes that plugins can implement. That's the is ready to start and on not ready to start methods. So basically, like for every Parker that gets registered as a like in a plugin, it can have its own logic to say whether a specific task is ready to start or it's not. And then it can have its own implementation on what it should be doing in the not ready to start. Like a simple example would be a Parker trying to acquire a resource in is ready to start, and then on not ready to start, it's going to say, hey, I'm going to release this resource. Like imagine the case where you have two Parkers registered. So one of the Parker is going to say, hey, I'm ready to start this task. And it says, okay, go ahead. And the other Parker, and then it's going to acquire a resource and says, like for example, it acquires a semaphore and say, okay, I'm ready. I got the semaphore to actually progress this task, but the other parker is going to say, okay, I'm not ready to start the task because I don't have enough semaphores based on whatever logic is being implemented in that parker. And since the second parker said, hey, I'm not ready to start, whatever resources were kind of acquired by the first one, you code it to release it in the on not ready to start method, basically. But yeah, if both of them are ready, then you just progress to running and then to stopping, and then from stopping to done. So that's the same. But after you go to stopping, there's a new stage here where we look for any other parked tasks that can actually be unparked. So okay, so before we come to that, maybe we can look at the case where the task is actually parked because one of the parkers said I'm not ready. So the task essentially goes to this new highlighted state parked. That's where the task will stay until some other task actually finishes running, and then will attempt to unpark that task. And when it attempts to unpark a task, it will redo the call to is ready to start for whatever parkers are registered at that time. Okay, so I hope some of that made sense. So as you can see here, when the task is parked, we still acquire the worker thread. So at the top, you can see that the thread is still acquired and the task goes to state parked. But we said that parked tasks don't deprive other tasks of threads, because as soon as we are ready to park a task, we also increment the core pool size of the pool. So that means there's one more thread available for another task to run. So essentially, parked tasks are actually not taking up threads, because when they are parked, they just increment the core pool size. And when they're unparked, they decrement the core pool size. So that way we kind of keep track of parked tasks not taking up resources from other, like not depriving other tasks from actually running. So yeah, this was merged on master sometime like a few months ago. So it should be available in 3.11 once it is released, likely next week. But using an interface like this, one should be able to implement quotas where they say, hey, we only want a specific number of commands to be running, and then you can have whatever logic that you want in your is ready to start and then on not ready to start methods. Okay, I'll try to show a simple example here where I have a sample plugin which implements this Parker interface to only allow a user to run one LS projects. So, so I just have a couple of scripts here. So one of them just runs show queue in a loop, and the other one runs LS project. So if I look at show queue here, it just runs it in a loop and sleeps for 0.5 seconds. And if I look at LS projects here, you can see LS projects being called 5 times for like a couple of users, like user 1 and user 2. So let me run show queue. Okay, so we can see okay actually running here, and now let me call the other one. Okay, so yeah, that like started 10 LS projects commands, 5 for user 1 and then 5 for the other user. And you can see here that because what I have in my plugin, you can see user 1 and user 2 running only one LS projects, and the rest of them all stay parked. And then as and when they start finishing their tasks, the other ones keep getting unparked, and then you can basically create quotas this way and say, if you know of specific commands that take up too many resources on your system, then you can have quotas using this to control how many commands a specific user can run at a time. And the configuration that I have in my plugin, it's not open source. I did not push it yet, but it can be if folks are interested to see. But my plugin just looks like this, where I have a config that says what's the per user permit for a regex, and then I say 1, and then the regex is anything that matches LS projects. So then I can have more configs in there, like for various different commands, and then I can say, hey, give me like 2 permits for queries and things like that, like whatever you need to do. But yeah, that's basically what that extension allows us to do. So one of the limitations of this is, since this extension was done in work queue, it does not work for HTTP because those tasks don't flow through work queue yet. But we can make updates to make HTTP either flow through that queue, or maybe have that interface in a location that is shared between both. Where are these tasks implemented in Gerrit core or in a plugin? The task Parker extension is in the work queue class in Gerrit core, but the rules that I have are implemented in a example plugin that I have on my local site. Are you using parking at all in production? No, not yet, but we are very close to using it. Yeah, if Joyce and Vasu will let us, then we will use it soon. Yeah. Okay, I think.
Yeah, so I'm just wondering, is this thing on? It is? Okay. I'm just wondering, can you like specify specific users or groups that the quotas apply to?
Yeah, it all depends on how you implement your plugin. Like for example, in my plugin, the implementation is per user, but you can do it per group as well. You essentially have to build the logic in those two methods that I showed, where you're basically looking to see if the user is belonging to a specific group, and then you implement quotas based on what the user is.
Could you use this to rate limit bots adding comments to changes in?
Yeah, rate limiting, I don't know if that's going to work, because you have to
quota, or well, same thing really.
Are you trying to slow down bots from making comments, or?
Yeah, this extension is probably not going to help there, because when you look at a specific task, either you're going to say, yes, this is allowed to run, or no. But maybe if you have historical, if you can look back and see if the user has been running too many of those similar commands over time, then you can say, okay, this is not allowed yet, so I'm going to park you until a specific amount of time. But that might be somewhat complex to do, but it's all in your plugin, so you can try to do it that way.
Yeah. No, that said, I think there already is a rate limiting plugin for something in Gerrit. There's a rate limiter, and there's an existing quota plugin. So the existing quota plugin works on the rate limiting idea, whereas this quota idea is like a
business logic kind of.
Yeah, it's right. It's more based on business logic of like what should be allowed to run concurrently, not at all, right? So I think the existing quota plugin does more of like a DOS prevention kind of thing of like you hit a certain number of requests over a certain time frame, I'm just going to start rejecting, right? Whereas this doesn't reject, it queues. Parks. Yeah. Dennis, yeah. Do we have any idea of what we'd be using it for? If we can share it.
Yeah, there are some commands like ls projects is one of them. It was bringing our primaries in a bad state because there were CI systems who would just run ls projects on all the projects. And we have like 30,000 projects in our site, and then you can imagine what that happens if they call it every 5 minutes and so on. So that's one of the use cases, but there are more that we want to build. Like for example, there are also instances where folks are trying to do fetches from the primaries, and we want to still allow it, but we want to limit it in a way that you don't try to do multiple fetches at once. Like you can still try to do it, it's going to work, but it's going to be slow. So you'll be encouraged to not override whatever default duties Qualcomm has to, like, because some people, they because replication is not as fast or not working properly, they just try to override the duties and say, hey, point my fetches to the primaries because primaries are going to have the latest code, so let me fetch it from there. And then they do like sync the entire code base of Android with 32 threads, and that all goes to a primary, and then the primary is struggling to handle all the other work that it needs to do. So in those cases also it will be handy for us.
Yeah. There's also use cases for like replicas. So like one of the use cases there potentially would be if say you have certain projects that are larger than others, right? Maybe nobody has this problem, I know. So you're like, okay, if somebody clones this project once, that's fine. If 5 people are cloning it at the same time, my replica is going to go down, right? Like it's bad. But you don't want to say, well, you only get 4 threads on that replica, because then most of the time people aren't trying to do 5 clones of that one project, and so you'd have a bunch of wasted resource potential, right? And so you could say, okay, well, limit that one project to only being cloned once at a time, right? But you can have 16 threads total, so you can have 15 other things going, but that one thing is really bad. So don't let anybody, no matter who they are, have more than one of those going at a time, right? And so you could potentially have kind of basically these quality of service kinds of policies to keep to make maximal use of resources without overloading. Yeah. The hard part is the testing, to know what are those limits. So write some AI for it,